Now I want to introduce to you, or let me just start over. Now I want to introduce to you some special forms that, if we can recognize, makes factoring a lot of fun. One is this idea of difference of two squares. And what a difference of two squares looks like, where maybe I have a polynomial that is a difference, means it's a subtraction, where both of the numbers on the other side of the subtraction are perfect squares. This is a perfect square. This is an x squared minus a 2 squared. So if I can recognize something in that form, it always factors into this pattern. Where in this case, a is x and b would equal 2. So then I would have an x plus a 2 and an x minus a 2. And that's how that factors. Let's look at another example. 81x squared minus 49. Can you recognize that as a difference of two squares? And if you can, you're able to use this special pattern that we have here. This is really 9x squared minus 7 squared, or I can write it this way if you want. So I have two numbers squared. My a is 9x, my b is a 7. So that factors down into 9x minus 7 and 9x plus 7. Factoring's done, if you can remember this difference of two squares. And I hope you can, because it's going to surface many, many times on your mathematical journey from here on out. Can you recognize 9 minus 16x to the 10th as a difference of perfect squares? Well, the 9 you can. That's 3 times 3. So let's rewrite that as 3 squared. 16? Yeah, I know that one. That's 4. X to the 10th. That's x to the 5th. X to the 5th squared is x to the 10th. 4 squared is 16. And 3 squared is 9. So now I was able to recognize what my a and my b are. My a is a 3, and my b is a 4x to the 5th. So if I use this pattern, this becomes 3 minus 4x to the 5th times 3 plus 4x to the 5th. That's right. So there's one use of the difference of two squares. Let's try 25x squared minus 4y squared. I'm waiting on you guys. Just follow along then. Is that what you were thinking? So then my solution becomes, or my factoring becomes, 5x minus a 2y in one term, and then it's pair, which is 5x plus a 2y. And there you have it, factoring by using the difference of two squares. Sometimes we don't recognize the difference of two squares right away. I recognize there's a difference, but not of two squares. So before I do anything, or before I start thinking about it, I notice I can factor something out of both of those terms. I can factor a 3x. And so when I do that, what's left? A 4x squared minus a 1. And what's left in the parenthesis is a difference of two squares. And I can rewrite it if you would like. This becomes a 2x squared minus a 1 squared. And now I can see those two squares a little bit easier. So my factorization becomes the original 3x that I pulled out first, then a 2x minus a 1, and a 2x plus a 1. Another example that we can see, similar to that, 80, is it 80x? 80 minus 125x squared. It's not a difference of two squares yet, but if I factored out something from both of those terms, I think I can factor out a 5. Then what's left is a 16 minus 25x squared. And that 16 minus 25x squared, classic difference of two squares. So let's just go straight to it then. What does it become? Well, I need to have the square root of 16 first, which is a 4. And then minus 25. One will be a minus 5x, and the other one's going to be a positive 5x. And there you have it, factoring by using the difference of two squares. And sometimes you're going to run into problems that's kind of like a difference of two squares on steroids. What do I mean by that? Well, let's factor this out. This is an x squared minus a 9 squared. So this should become x squared minus 3, minus 9, and x squared plus 9. I'm left with, let me rewrite that so it's a little bit easier for you guys to see. So x squared minus 9 and an x squared plus a 9. What do you notice? I have another difference of two squares. This x squared minus 9 can also be factored using the difference of two squares. So that factors down to x minus 3 and an x plus a 3. And this x squared plus 9, well, it's not a difference of two squares, but it's a summation of two squares. Can we do anything with that? No, unfortunately we can't. So this just remains x squared plus 9.